Very good morning to all. Today we are going to see about energy efficient building. First of all, we are going to see about a conventional building versus energy efficient building. What do you mean by conventional building? Conventional building is nothing but a structure designed and constructed using traditional methods and materials without a primary focus on energy efficiency or sustainability. This building meet basic functionality and safety requirements, but often having higher energy consumption and environmental impact compared to energy efficient or green buildings. So conventional buildings are normal buildings. They are not focusing about energy efficiency, energy savings. What about energy efficient building? Energy efficient building are designed to minimize energy consumption while maintaining comfort, functionality, and sustainability. These buildings use advanced construction techniques and technology to mainly reduce their environmental impact and cost also. These are the main tabulation for a comparison between conventional and energy efficient building. In that first, we are going to see about energy use. In that higher energy consumption due to poor insulation and outdated systems. In energy efficient buildings, lower energy consumption through efficient design materials, insulation, basic insulation. Here, high performance insulation mainly reduce energy waste. Lighting. So normally fluorescent bulbs. Here, LED lighting and daylight optimization. HVAC systems, the standard heating and cooling with high energy use. Here, energy efficient HVAC systems. Building materials, the conventional materials, example concrete and brick. Here, sustainable materials with better thermal properties. Here, water use, standard fixtures, higher water consumption, low flow fixtures, rainwater harvesting. Renewable energy, rarely integrated, often includes solar panels, wind energy, or geothermal for energy efficient buildings. Then ventilation is basic ventilation, here advanced ventilation. The cost is about a lower upfront cost, but higher operational cost. Here, higher initial cost is higher, but maintenance cost is very low. Energy, environmental impact, here higher carbon footprint, here the reduced greenhouse gases and eco-friendly. Advantages of energy efficient buildings. First of all, lower energy bills. It's a very important advantage. Then reduce the environmental impact. We're focusing on sustainability SDG goals. So for the reduce the environmental impact, improved indoor air quality and comfort, compliance with green building certifications. For example, LEED certification is a very important certification for energy efficient building, for green building certification. Increase the property value is a very important thing for energy efficient building. Historical perspective, something but ancient and traditional practice. In the historical perspective, vernacular architecture plays a major role. The style of building that reflects the local culture, climate, and materials of a region. Vernacular architecture can be defined as a type of local or regional construction using traditional materials and resources from the areas where the building is located. Materials used for vernacular architecture is timber, bamboo, earth, and bricks, straw. Then another important traditional practice is passive solar design. Indigenous people in North America and Middle East building structures using thick adobe stone walls. They're mainly using for then mainly absorb heat during the day and release it at night. Then wind catchers and cooling towers. It's a very oldest building for wind catchers, mainly used for collecting more winds in ancient Brazilian and Middle Eastern architecture incorporated wind towers to funnel cool air into buildings, reducing reliance and on artificial cooling. Wind catchers and cooling towers are architectural features that use wind to cool buildings. They are also known as wind towers. Wind towers often referred to as wind catchers are a traditional architectural feature found in certain regions with hot and arid climates. These are diagrams for traditional cooling towers and wind catchers in Dubai. These are the vernacular architecture. It's found in African countries. This is a passive solar design. In summer, the orientation of sun is there. So in winter, the orientation of this sun is there. Then the heat. This is the first diagram shows the design. In summer, the rays will pass to the house. Then winter, the heat will be allowed into the house. Equator facing window. Shading is there. Equator is there. Thermal mass flooring is there. It's mainly for reduced openings or non-equator facing wall, skylight openings, insulated roof walls. Water energy. This is a very important parameter in energy efficient building. And the definition of water energy is energy derived from the movement of water is called water energy. It is one of the oldest and most widely used sources of renewable energy. It is also known as hydropower or hydro energy. Types of water energy. First one is hydropower. Second one is runoff river hydropower. Third one is tidal energy. Fourth one is wave energy. Fifth one is ocean thermal energy conversion. So these are very important types of water energy. The advantages and disadvantages of water energy. First of all, advantages. First is renewable and sustainable, low greenhouse gas emissions, reliable and consistent energy storage. These are the advantages of water energy. What are the disadvantages of water energy? Environmental impact, high initial cost, dependence on water availability. What is our very important parameters? Indoor air quality requirement analysis. That means of IAQ requirement analysis. Indoor air quality requirement analysis is the process of evaluating and ensuring that indoor air meets health and safety standards for occupants. This is essential in residential, commercial, and industrial buildings to maintain comfort, health, and productivity. What are the key factors in IAQ requirement analysis? Air quality parameters to monitor. The first is very important parameters. What are all the air quality parameters to monitor? First is carbon dioxide, then particulate matter, PM 2.5 and PM 10, volatile organic compounds, then carbon monoxide, humidity levels, temperature, ozone and nitrogen oxides. Then IAQ standards and guidelines. AS-ASHRAE 62.1 and 62.2. This is standards for ventilation and acceptable indoor air quality. Occupational Safety and Health Administration means OSHA, Workplace Air Quality Limits. EPA is nothing but Environmental Protection Agency, Air Quality Regulation and Pollutant Limits. WHO is a very important thing, World Health Organization. This is for global air quality guidelines. Natural ventilation requirements. For natural ventilations, open windows and cross ventilations, we are going to adapt for this. Mechanical ventilation is nothing but HVAC systems, air purifiers and exhaust fans. Then air exchange rates. These are the ventilation requirements. Then air quality improvement strategies. First one is the filtration systems, then humidity control, source control, air purifiers, green building design. So these are very important strategies for air quality improvement. Then future building design aspects. It's nothing but the sustainability and energy efficiency. It's mainly focus on future buildings. We will design for the strong emphasis on sustainability, technology integration, and occupant well-being. Some key aspects. First one is sustainability and energy efficiency. In that, net zero and carbon neutral buildings is a very important thing nowadays. We are focusing on buildings that produces much energy as they consume using solar panels, wind energy, and advanced insulation. Green buildings materials, use of recycled materials, biodegradable materials, and low carbon materials. Then smart climate control. Smart climate control, AI-driven HVAC systems that optimize energy use based on occupancy and weather conditions. Then passive design strategies. Maximally, we are using natural light to reduce energy consumption. The smart and adaptive technologies, IoT integrated buildings, energy storage and grid interaction, AI and automation, dynamic forecasts. Health and wellness oriented design. That first enhanced indoor air quality, IAQ. This means advanced air filtration, water conservation and recycling, smart plumbing systems. We are introducing smart plumbing systems, rainwater harvesting and wastewater recycling for that. Human-centered lighting. Tunable LED lighting we are implemented in energy efficient building. Active designs for staircase, green spaces and fitness centers. Resilience and disaster ready infrastructure is nothing but mainly focusing on disaster system structures, mainly for modular and prefabricated construction. It's faster, cost coefficient, and flexible building methods. Then climate resilience is mainly focused on fire resistant materials, flood proof structures, extreme weather ready designs, off grid capabilities. 3D printed buildings. So nowadays we are mainly focusing on 3D printed buildings, rapid, low cost and sustainable solutions. Urban integration, mobility, walkability and mixed use development, EV charging and smart parking, green roofs and vertical gardens, transit oriented development, TOD. LEED certification. So very important certification. LEED certification is nothing but leadership in energy and environmental design. What is LEED? L is leadership, E is energy, E is environmental, D is design. Leadership in energy and environmental design is a globally recognized green building certification system developed by the US Green Building Council, USGBC. It sets standards for sustainable building construction, design, operation, and maintenance to reduce environmental impact. LEED certification levels. First one is certified means 40 to 49 points. Silver means 50 to 59 points. Gold means 60 to 79 points. Scoring platinum means 80 plus points is starting. So different levels are there for LEED certification. LEED rating systems. Mainly for LEED for building design and construction, LEED for interior design and construction, LEED for operations and maintenance, LEED for neighborhood development, LEED for homes. That means residential buildings. Steps to lead certification is first to research the project, then develop a sustainability plan, documentation, and we are going to submit the documents to US GCPC reviews there. After that, the certification will be awarded. Thanks for listening.